Twitter has a small VM team. So we are about 4 core people working on the JVM. We have 2 other team members that are doing slightly different things. But we have 3 GC engineers. And the GC engineers are basically 24/7 busy fixing all the GC issues that the whole world has, right? And us too. And then I'm the compiler engineer, and I do the fun stuff. So, and then I tour the world and tell people about the cool things that we've done at Twitter. And if you're going to tweet about this talk, please add that hashtag, TwitterVMTeam, so that my people at home know that I was actually here. So what's the goal of this talk? And it is to save money. That's the goal of this talk. So I'm glad you're all here. I'm going to sell you some stuff if you want to. No, I'm not. But I'll talk about the money-saving part a little bit later. So I don't know if you guys know me. My name is Chris Thalinger. I work on JVMs for a long time now. I was always a compiler engineer. And I see some older faces in here, so at this point I'd like to call out people. I'm not sure if it works here too, because I usually speak at Java conferences. So who remembers GNU ClassPath? Yeah, some people. Okay, like 2, 3 old people over there. So back in the day, when Sun still had Java closed source, there was something called GNU ClassPath. It was an open source implementation by GNU of the Java class libraries. He remembers now. Oh no, GNU. Yes. Yeah. Oh, exactly. So back in the day, we were working all on this stuff, and we were the Wild West, and we tried to liberate Java, right? And Sun, they were the bad guys, and we all met up at FOSDEM in Brussels and drank a lot of beer, and that was a lot of fun. And then in 2007-8, Sun open sourced Java finally, and then they showed up at FOSDEM 2. And we thought, oh yeah, you guys are actually cool because they bought us beer, and you know how the world works. And then a few years later, I started to work for Sun, and then we got acquired by Oracle. And I was always part of the Hotspot compiler team, so I was working mostly on C2, a little bit on C1 interpreter stuff as well, but mostly C2. And then these are kind of the 3 biggest things that I've worked on during my time at Sun and Oracle. It was one JSR 292. I was working on Invoke Dynamic. I basically wrote all the compiler support for Invoke Dynamic, a little bit of interpreter support, ported all the stuff to Spark, and whatever comes with that. So John Rose and I, we've done this for quite a while. And then there was a problem with the first implementation of that, and then we had to re-implement a lot of stuff, and we moved a lot of logic from the VM into Java. And so I wrote a lot of that Java code too. If you ever heard about Lambda forms, maybe not, it's like an internal implementation detail. So if there is an issue of a bug, you could technically blame me. Don't do that, because I think my code was perfectly fine, and the people who touched it after me, they broke it. Okay, then we were doing JEP 243, the Java level JVM compiler interface. We're going to hear about this a little bit later. So we introduced this, we took the interface that Graal had and basically extracted that and made it an official API in a way and put that into JDK9. So the idea behind it was we put it in the official OpenJDK, Oracle JDK distribution, and then you could just grab an external JIT compiler and plug it in. That's the idea behind it. And then we also did JEP 295 ahead of time compilation in JDK9. And the ahead of time compilation in OpenJDK uses Graal as the code generating backend. So it's basically a command line tool that loads in class files and then sends it over to Graal, and Graal compiles it, and then at the other end, you get a shared library out of it. That's pretty much how it works. And so it's also using JVM CI. And now I work for Twitter. Great company, love it. Okay, I'm pretty sure you know what Twitter is. It's a huge distributed system. Obviously, we are using microservices, right? So we have a tweet service, a user service. These are kind of the biggest ones we have, right? It's kind of all these 4 pretty much make Twitter, and then there are a bunch of smaller ones as well. So we have many JVMs per service, obviously. We have thousands of machines running thousands of servers, and we have multiple data centers. So it's kind of big. It's maybe not as big as Amazon or Google, but it has a good size. And so Twitter in general, we're doing a lot of open source. We love open source. We also give back, so we use a lot of open source in our product services, whatever we do. We also give back to the community a lot. There's this GitHub IO, I always forget what it's called, like there's a Twitter thingy. And so for us, so everyone knows what Graal is, right? I didn't ask that question. People know what Graal is, right? I should say, I'm not talking about Graal VM, okay? If you came to hear about Graal VM, you're in the wrong room. I'm not talking about Graal VM. Graal VM has more technologies in it. I'm talking about Graal, the JIT compiler, okay? So Graal VM has basically Graal, the JIT compiler, Substrate VM, and Truffle. That's kind of what Graal VM is, right? But I'm only talking about Graal, the compiler, nothing else. So Graal for us, since it's open source, is a good fit. You know, we just include it in our JDK and then we run with it. And we're also contributing back to Graal a little bit. So I'll show you an example later what we did. We have our own JDK, kinda. You know, it's basically a clone of OpenJDK 8U. Yes, we still run on 8. And so we backported CHEP 243 because I said we included it into 9, but we backported it to 8. We have a copy of Graal, which is a one-to-one copy of what you can get on GitHub. There are no changes. Then we have something that's called Contrail that will go away pretty soon because Oracle decided to open source JFR. So it's basically the same thing as JFR. And we had CMS improvements. I think that's not the case anymore. We upstreamed all this. So, okay, why Graal in general? So why would we want to run on Graal? Or why do we want Graal to be part of OpenJDK? So C2, do people know what C2 is? Okay, no. So C2, okay, people know what Hotspot is. Yes, the JVM of OpenJDK, okay. So Hotspot has 2 JIT compilers. You know what JIT compilers are, just-in-time compilers, yes. They take Java bytecode and during runtime, on the fly, just-in-time compile it to native code so the application runs faster. That's a JIT compiler. And so Hotspot has 2 JIT compilers called C1 or client compiler, and the other one is called C2 or server compiler. You might remember the dash client, dash server thing you used 10 years ago, or maybe not 10, but 5. So that's not required anymore, but the compilers are still there. So, and C2 is very old already. I'm not even sure how old, at least 10 or 15 years. And it's very old and very complex. So I've worked on C2 quite a bit. I've fixed a lot of bugs. The learning curve of C2 is very, very steep. So these days, everyone is very impatient, right? You grab a framework from GitHub and you look at it for a week or two, and then you expect to understand it, or after a month or two, maybe. I started to work on C2, and it took me about 3 to 4 years to fully understand how it works. Okay, so we had an issue around the time when Oracle acquired Sun, that we lost a few people of the Hotspot compiler team. And then we had to hire new people, okay? Some of them have never worked on a compiler before, some did, but they've never worked with C2 before. One of the problems was that some of them got frustrated and then left after, you know, a year and a half or 2 because they realized, I mean, I don't know the exact reasons, but I'm just speculating. They either thought, okay, I'm stupid, I don't understand this, or whatever, right? So it's a big issue, especially going forward, because the JVM, in my opinion, is not going away anytime soon, because a lot of the cool new languages like Scala and Kotlin, they run on top of the JVM and leverage the JVM because you get scalability and GCs and all this stuff for free and the performance. So it's not going away, but we need people to understand the JVM, right? So we need to replace C2. And so there's also, in the last at least 4 years, or maybe even 5, there were no major optimizations done in C2. Yeah, there were some intrinsic work going on in Intel. You know, Intel is coming out with new AVX and SSE instructions wider and wider and wider. Yes, we have some handwritten assembler code intrinsics. They were added to C2, but there was no, okay, let's re-implement escape analysis or inlining. Nothing like this happened. And one of the reasons why this didn't happen is because it's so complex. No one didn't want to touch it. It works for everyone in the world pretty much, so it's difficult. And then, in my personal opinion, C2 reached its end of life a long time ago. So, on the other hand, Graal is already, I'm not even sure how old it is now, but it's at least 5, 6, 7 years old, I think. But from ground up, the design is much different than C2's. So it's a very modular design, and the build system makes sure that you're not breaking this modular design. It makes sure that you don't have circular dependencies. It makes sure that architecture the other way around, architecture independent packages or modules, what they call it, are not depending on architecture dependent stuff. All these things that you don't want. You don't want this spaghetti code that everything touches everything. And so Graal has a very good design in that regard. And then very, very important at the bottom, it also has a better inlining implementation and a better escape analysis implementation. So I'm not going to explain this in detail, but we're going to talk about this a little bit later when we talk about performance numbers and graphs. Okay, so I started to work for Twitter about 2 years ago, and so what I'm going to show you is pretty much the first year I was at Twitter. When we started running stuff, one of the reasons why I left Oracle and went to Twitter is I wanted to use Graal in a production environment. I wanted to see how it works, if it works, right? And so we started running our services, and then these were the bugs we found, okay? So I'm going through these a little bit. If you don't fully understand what's going on, that's fine. So we had this one issue where we had like this, when you compile stuff, sometimes the JVM can't compile methods for some reasons. And in this particular case, it was not able to do this on-stack replacement compilation, and then the output looked like compile skipped, OSR with logs not supported, right? And then it threw an exception because Graal is written in Java. So you get an exception out of it, kind of looks like this, and you see, oh, there's an on-stack replacement phase, and it's trying to do stuff, but it can't, okay? So we discussed this. So I saw this in our logs. When I was turning on print compilation, I saw this, and so there's an Oracle Labs employee, Tom. We discussed this for a little bit, and we decided that it's not really a big issue because all of you pretty much are running by default in tier compilation. Do people know what tier compilation is? Kinda. I could explain it. It's not that important for this talk. But it basically, you compile with C1 first and then later with C2 to get peak performance. So if you can't compile with your top level, with the top tier compiler, C2 or Graal, you still have C1 compile code. So you're not running interpreted, you're still running on native code, and that's good enough. And in this particular case, the method was not very important. It got compiled after a while. It was something that was used enough, but not really in the hot path. So we said, okay, it's cool, doesn't matter. Turns out that completely independently and a little bit later, this guy fixed it. And it was about, 1,000 lines of new code. So it was quite a bit. And so I'm saying technically it's still open. And so I looked at, I verified that it was actually fixed. I was running the service again, and I was seeing these other exceptions, the top 2 ones that are saying no on-stack replacement node generated. And so it turns out, does my mouse cursor? No, it does not. So it turns out, as Tom says, he looked at this code and then he says, there's a problem with de-optimizing on static field access in the static class initializer, okay? And then he looked a little bit deeper into the C2 code and he said, oh yeah, there's some small logic in C2 that handles that. And that little bit of logic in C2's parser is this method that's called static field OK and CL init, okay? So the problem is you're compiling your static class initializer, and the static class initializer makes sure that your final fields are initialized, but you actually need them when you compile the code, so it's like a catch-22 situation. But since you are the compiler, you know it's fine to access them because you know the value, okay? And then important, like the last line of the comment says, better to check now than to de-optimize as soon as we execute. I don't know if you know what de-optimization is, but it's basically you run your natively compiled code and then something happens that you didn't expect, and then you fall back to interpretation, which is bad, okay? So in this case, you all know that the static class initializer is only run once, okay? Usually they're not compiled, but if you are going to compile it, it means it's either very long or it has loops in it, right? So it's kind of important when you load a class that this finishes fast, because the whole system's basically waiting for you to load that class. So if we're already waiting for this class to be loaded, and it takes a long time, and then we have the time to actually compile it, and then we compile it in a way that we're immediately de-optimizing and fall back to the interpreter, we wasted a lot of time. So we have to make sure that this works good and fine. And so the fix was then to add that little piece of C++ logic in Graal, and you can see it was like 31 lines of code. So that was fixed. That was good. Then we had this one that was actually a crash, a segv, with this very long fatal error message. And the important one is here, where it says long-running processes couple days. So I was running a service, and after a couple days it crashed. And I had no idea what the hell was going on. And then I was looking at the stuff that we were doing, like on the command line, with the things we were loading and running and passing to the JVM. It turns out that we're using something called Heapster. And Heapster is an agent that does heap profiling. Okay? So agent means it instruments bytecode. And if you're profiling, if you do heap profiling, you basically have to instrument all the new bytecodes when you allocate memory. You're collecting all the types of classes that you're actually allocating. So we discussed this a little bit. This is all like this. These are screenshots from GitHub, issues. So you can just go there and read it all up what we discussed. So so Doug says, well, it turns out, since Graal is written in Java, right? And it has something that's called snippets. I'm not going to explain it too much in detail. It's something like an intrinsic, and the compiler handles it in a very special way. And so there's a snippet for the double value off thingy here, and it uses double dot value off. And double dot value off does a new. Okay? So the agent instrumented the bytecode that Graal handled in a very special way, but then it suddenly changed the bytecode and made it bigger and introduced new bytecodes in there. And then the bytecode and the compile code didn't match up anymore. That's where the crash came from. And then, Tom then said something, and then Doug says maybe it's time to bite the bullet and parse the bytecodes for snippets in a special way, which they did. And it added 2,700 lines of code. So this, and it deleted 400, so like 2,500 new lines of code. This never happened. This never showed up in internal testing at Oracle, but it's something that happens outside in the real world. Like we all use agents for stuff, and so this was an important bug to find. Because as I said, people do this all the time. Good. Bug number 3. So I was running some stuff, probably the tweet service. I can't remember, and then I was looking at the logs, and every now and then I saw like a ton of exceptions, flying by. And I really didn't know where they were coming from. The bad thing about, and you probably know this better than I do, because I know nothing about microservices, but the bad thing is, if you have a microservice architecture and something goes wrong, you don't even know where it's coming from, right? Especially if it's a connection exception. Is it yourself? Is it the guy you're talking to, or is it the other guy you're talking to? You don't know. And so for me, I'm not an expert in all this. I really didn't know what to do at this point to figure out where this is coming from. And so at one point, I think what happened was we were updating from Netty 3 to Netty 4 or something like this. I can't remember. So I decided to run the Netty 4 test suite. And so I was running it, and then Netty buffer, boom, failure. Thought, okay, yeah, that's interesting. Maybe we should look into this. And so that's a very interesting bug. So it turns out, you guys know the reverse bytes method on the number classes, short dot reverse bytes, it basically swaps the bytes. So it turns out that was wrong, that got compiled wrong. And this is done all the time, right? But in this particular case, it didn't work. And then Tom says, oh, it does an incorrect canonicalization, blah, blah, blah. So it turns out the fix was a 2-line fix, right? It's 68 lines of code because Tom added a test case. But it was a 2-line fix, really. So very, very interesting. Like through testing, all the years never happened. But suddenly, in a real world scenario, it happened. And this, I think, yes, these were all the bugs we found. Since then, no bugs. And I think the last one we fixed is there actually like a date, like September 2016. Okay, that's a year and a half ago. And since then, no issue. So these were, you see that they were kind of, especially the agent one was kind of related to stuff that we were doing and so on. So Graal is a very stable compiler, to be honest. Yeah. So since then, we didn't have an issue. So then, let me tell you about one thing I did. I didn't have a lot of time to actually do some work on Graal, but one thing we did was, you know that in JDK 9 we have something called compact strings now. And compact strings, the way it was implemented, it's a little unfortunate, but it was implemented with handwritten assembler intrinsics because C2, I wanted it to be implemented with unsafe, but C2 couldn't optimize the code so well. So Oracle decided to actually write, the assembler by hand, which is annoying because that means you have to do it in Graal as well. Okay, so we started doing this because that was before the whole Oracle new release cadence, was announced, and we thought we're actually moving from 8 to 9, and we thought, okay, we should implement this because there's a performance impact then. And so there's handwritten assembly code in C++ for all SSE, AVX, AVX 512, and so on and so on. So we needed to port that over to Graal. This is basically one of the benchmarks, and if you look at the third line, that was Graal before, and it took, 2,600, whatever that is, nanoseconds per operation. And then with the intrinsics, it's 126, right? So this is just to show, this is not any better than C2, it's exactly the same. It's just we need feature parity in Graal, what we have in C2. So we did this, then I started traveling and do all these conferences, so I couldn't finish it up. But Dimitri, fortunately, he fixed that. And as you can see, we had to port over about 1,000 lines of handwritten assembly code into Graal. And I just saw a ticket today because there are 3 or 4 more smaller methods that need to be brought over. And I just saw a PR for this today. So someone at Oracle is working on this to get it in before, I hope before 11 comes out. That would be good. Okay. This is the interesting part. So now we're talking about numbers. And I'll show you a bunch of graphs. So the tweet service at Twitter is a finagle thrift service. You guys probably know what finagle is. I don't really. It's an extensible RPC system for the JVM, I don't know. Most important thing, it's 92% Scala code. You guys know what that is, right? I can't write a single line of Scala code, by the way. I really can't. But I don't have to, because everything I speak is Java bytecode. So the tweet service runs with that stuff, right? So almost all of our microservices are written in Scala. And I've given this presentation many, many, many times in the last 8 months, and usually at Java conferences, okay? And that was important, to show people what Graal could potentially do for them. But to be honest, this is the last conference for me for a while, and this is actually the most important one, because you're Scala people. And Graal works really, really well for Scala code. And you will see that in a minute. Okay, so my test setup was, I had a dedicated machine per instance configuration. I had dedicated machines because in our production cluster, you have multiple things running on the same machine. There's a lot of crosstalking going on, and so you want to get that out, and you want really good numbers, benchmark numbers that are not distorted. And then all instances receive the exact same requests. That's important, not the same number, the exact same request, and that's important because a tweet could be 1 byte long or a tweet could be 280. And there's a very different allocation pattern if you do this. So all of the instances receive the exact same requests. We run with that version of JVM CI and Graal, not that important. We use the default tiered setup. That means we start up and then we compile with C1 and then with Graal. That's what we do. Since 8 we don't have AOT, we do this. If the Graal bootstrapping would be an issue for you, I'm not going into the details here. There's another talk. You can find it on YouTube. Maybe I'll mention it later again. I can't remember. It's how to use Graal in real life. So Google for it or search on YouTube for it, and then I'll explain all this, the bootstrapping part, that it's not an issue. But if it would be an issue and you run on 10, 9, or 10, and I'm pretty sure everyone in here is running on 10 in production today, yes. You could technically AOT compile Graal, and then the bootstrapping would not be a problem. Okay, so let's see the numbers and look at the graphs. It's good that it's actually cut off here on the left. This is 24 hours of tweets, right? So you can see, and then one thing you can't see, that's why I say it's good, there is no y-axis. And the reason why there's no y-axis is because I'm not allowed to tell you. Okay, but I'll show the numbers to you in a way that you will understand and see how much we're saving here. So we are comparing C2 of JDK8, then Graal, and then I'll also put in JDK9 numbers just to see if there would be a difference. Okay, and the important thing to see on this slide is that they're all the same. Okay, good. So the tweet service uses parallel GC. And so we're looking at scavenge cycles here. There's a moving average of 60 minutes, so it's a little smoothed out. It's easier to see. So this is C2. And as I said earlier, that Graal has a better escape analysis implementation. So what we would like to see here is less scavenge cycles. Okay? So let's look at this. And actually, yes, that's the case. That's very good, because that means we're not allocating so much memory. And it means then we don't have to collect all this garbage. Okay? We have the same for 9 and the same for 9. And this is roughly a 2.5% reduction in cycles. That's not a lot, but it's something, right? If you don't have to do 2.5% of the cycles, you save, right? Then, you know, when SREs, so people who take care of their services, they very closely look at their metrics. And some of them, when they started running with Graal, they were screaming, oh, memory leak, memory leak. And what they saw was, here at the bottom, like a 40% increase in old gen usage. And the reason for this is Graal is a Java application. It has some state, and it's 40 megs, roughly. But that's not a ratio of your old gen, it's just 40 megs, right? It doesn't matter how big your old gen is. If it's 100 megabytes, it's 40. If your old gen is 2 terabytes, it's 40 megabytes. Doesn't matter. It's just the state you have. And then the same, I don't have a graph for it, but the same is the case for metaspace, right? Because you have to load classes. Like the classes take up some memory, and that's roughly between 20 and 30 megabytes. So it's not the end of the world, really. But people complained about it, and rightly so. And it was good they did. Most important graph. User CPU time. What we really want is to save user CPU time, because that means we can reduce the size of our instances, of our clusters, basically. Okay, so this is C2, and this is Graal. That's really nice. We can't tell yet how much it is. This is 9. It seems it's better. I don't think it really is. What can happen sometimes is that inlining decisions are done differently on different runs, and so I don't think that actually C2 was improved in that case. And then, as you can see, Graal with 9 is exactly the same. So let's put this in a ratio graph, and you can almost, not really, see it on the side here, but it's 11%. 11% reduction in CPU utilization is huge. I don't know how many compiler engineers are in this room. There's at least one. Usually there's none, but there's one. If you write an improvement and make an improvement in the compiler, in a native compiler, and you get 1%, that's cool, right? If you get 2%, that's great. But if you get 11, it's ridiculous, right? And we just switched out the JIT compiler. All right, so the tweet service, as of today, and for about a year now, I think, because it's June now, Twitter's tweet service runs 100% on Graal in production. And we didn't have an issue since then, by the way. And yeah, you should tweet that right now. So you try it out if it actually works, or if you're losing a tweet or something. Oh, it runs fine. And then we're also running the other bunch that I mentioned earlier at the very beginning, like the biggest services we have, the social graph service and the user service, they're also running 100% on Graal. Plus another, small number of other services that are not that important, but these are our biggest ones in terms of instance size. And so that's where we save most of the money. Okay, interesting for me was this 11% of reduction in CPU time, where's it really coming from? Is it just the escape analysis? Is it because we don't have to allocate these temporary objects? That means your code gets tighter, you don't have to collect them, Is it that? So I made an experiment and looked at this, and I just ran the tweet service again and turned off escape analysis, okay? This is basically, again, the request for 24 hours. The graph is different because I ran a different experiment. And this is, again, the scavenge cycle graph. And here, that now, because we have turned off escape analysis, should be exactly the same. And it is. So that works fine. So we're comparing actually apples to apples. And so here is the user CPU time without escape analysis, and here it's with Graal. So there's even an improvement without escape analysis. And again, ratio, and it's 5%. So just the better inlining implementation in Graal can give you a 5% improvement with your Scala code. Again, remember, this is all Scala code, right? That was very interesting to me because I thought it's probably mostly escape analysis, but there was a lot of inlining as well. Okay, so how much money are we talking? Well, I can tell you. I couldn't. What do you think I can tell you? I couldn't even show you a y-axis. Do you think I can tell you? Of course not. So we're making up a fictitious company. And we do a little back of the envelope calculation too. I don't know how many people are in here that have data centers and they are familiar how much it costs. I didn't know it, so I was just Googling for some cloud providers how much they actually charge, right? And so I calculated that out per CPU core dollars per year. It's like between what, $72 and $210 per year per CPU core. Number one takeaway from that slide: if you're choosing the wrong cloud provider, you're screwed anyway, right? No compiler can help you save money if you pick the 210 one. But I didn't know, so I took the average of $127 per year per CPU core, really. So how many cores are we talking, right? Again, I can tell you how many we are using, but there is a Bloomberg article from 2014 that talks about Amazon and Google and Microsoft, and it says, where does it say that? Amazon, here, a conservative estimate puts Amazon over 1.5 million servers globally, and then this other person at Gartner says 2 million servers. Okay, servers, right? A server has usually 24 cores. So these are ridiculous numbers. And then at the bottom it says about Microsoft, 17 regions, blah, blah, blah. Steve Ballmer said the company had over 1 million servers. And Google had even more. So it's humongous, right? But obviously your company is not as big as Google, I'm assuming at least. So we're just picking a random number of 10,000 servers. Maybe it might be a little bit too big, but if you run a decently sized operation, maybe that's okay. So you have 10,000 servers with 24 cores, that's $127 per year per CPU core, times 24 times 10,000 is $3 million to just run whatever business you're running. Okay, that's your expense. If you could save 11% of that, that's a nice chunk of money. It's more than I get paid. I don't know how much you guys get paid, but it's more than I get paid. So 11% is really nice. But as we've seen from this one graph, it's a lot inlining. It's like half-half, roughly. It's inlining and escape analysis. So the question is, what if we inline a little bit more? Can we actually get more out of it? And so what I did was, I sat down one afternoon. I was just fiddling around with inlining parameters for like 2-3 hours or something like this, like manually changing them, looking at log output, what could we inline more, tweak this a little bit, blah, blah, blah. So I did this, and I ran the experiment again, and I actually ran that experiment at the same time as my first experiment, so you've seen that graph before. And then we have this new color, the purple, that's my experiment with the changed inlining parameters, okay? Again, scavenge cycles, you know that graph, you've seen it before. And I actually could squeeze a little bit more out of it. And it's roughly a 1.5 reduction, right? 1.5% reduction, which is pretty good, actually. And then the user CPU time graph, you've seen that before, and yes, better. And that's an additional 2%. But just screwing around a little bit, really, right? And then the 2% was what? The $300,000 we had, so 2% is like $60,000. We're just fiddling around for 2 hours. That would be nice. I didn't get it, but that would be cool. So this is obviously, no human should sit there and do this, right? There's a buzzword that could do this. It's called machine learning. And we're actually doing this, by the way. And so I'm not going to tell you too much about it because that will be my next talk. So next year when I come back, I'll tell you about that. Your company, I'm pretty sure, does not have its own VM team. So for you, support is probably important. So how good is Graal supported by Oracle or OpenJDK? So as I said earlier, JDK 9 contains Graal because AOT is using it. And then since I was working on it, I made it so that you actually could use it as a JIT compiler in 9. No one knew that, but we made it that way. I was at FOSDEM this year, and I was talking to John Rose and Mark Reinhold about it. They watched my presentation, and then Mark Reinhold later came up to me and said, I didn't know you could use it as a JIT compiler. I said, well. So you can in 9, but it's even better because there's CHEP 317 in JDK 10 now. And basically, Oracle put it in there officially. So still experimental, but it's there, and you can turn it on with these flags that I just showed you here at the bottom. So that's kind of the closest you can get right now to being supported. It doesn't really mean you can't get the real support by Oracle, but if something goes wrong, if it crashes, you can at least talk to them, and they will probably fix it, or Oracle Labs people, whoever, right? Yeah, this is the other talk I was mentioning earlier. How do you use Graal? So just Google for that one, watch it. I'm doing it's basically one hour of just demos. I fire up a completely empty cloud instance and then download everything you need and show you what to do to actually run. I show a bunch of benchmarks, tell you about bootstrapping, Java memory heap usage, and all these things. And it's actually not that scary. So, and I say it again, we're using this in production today, like for a very long time, and it's perfectly fine. Then there is something called Project Metropolis, which was proposed like in September last year by John Rose. And at the bottom, it says, our starting point is earlier proposals for using using the Graal compiler and AOT static compilation technology to replace the hotspot server compiler, C2, exactly what we want. We want to get rid of it, and possibly other components of hotspot. So what this says is that we would like, Oracle and the OpenJDK community would like to rewrite parts of hotspot in Java. The perfect example is the compiler, because it's an optional module, right? The GC, don't implement the GC in Java, it's not a good idea. But you could do other things, like you could do the bytecode verifier, would be super easy, or hopefully the interpreter, that would be great. So I don't think anyone's actively working on this yet. I know there is some work being done with getting Substrate VM into hotspot so that this AOT compilation and the bootstrapping goes away. But this is a very nice project. If I didn't work for Twitter, I would probably work on this stuff. OK, so lastly, this slide is just here for all the Java conferences I was mentioning earlier. I don't really have to say this today, because your stuff is probably written in Scala, right? So, but with Java, it's slightly different. I'm just mentioning it. The reason is, I don't know if you guys have ever looked at the bytecode that Scala C produces. It's horrifying. It's like when you look at bytecode that Java C produces, it's very flat. It's very easy to read. If you look at Scala code, it's ridiculous. It's very complicated. Scala has a very polymorphic nature to it. It allocates a lot of temporary objects, all that stuff, right? So the inlining and the escape analysis here really comes into play. When you run Java, then Graal can't do that much, right? And it's also, C2 has been optimized for all the Java code out there for a long time. But more importantly, the Java code has been optimized for C2. Right? So if you suddenly bring in a new compiler, it's very difficult to run that code better than with the existing one. It's like, my rule of thumb is it's a 50-50 chance if Graal runs your Java code better or not. I've seen it. I've seen benchmarks that run much better, up to 10%. I've seen benchmarks that actually run slower. So it's whatever. Your mileage may vary, but again, you're Scala people, so it doesn't really matter. OK. That was almost it. My summary for this talk is this. That's really all I want. So I'm giving all these presentations for the one reason I want you to try it. And the reason I want you to try it is because we want to replace C2 in OpenJDK with Graal, but it's not going to happen until it's a mature, stable compiler, right? Otherwise, Oracle will never make it the default compiler. But the problem is if it's not the default compiler, no one's using it. Is it a catch-22? So that's why I'm touring around and encouraging you to give this a try. And again, you are Scala people. I give you a 99.9% assurance that your Scala code will run faster with Graal. I've not seen Scala code that runs worse. So give it a try. It's very easy. When you run on 10, it's very easy. You could probably not run it on 10 in production, but maybe you have some experimental setup somewhere or a pet project or a new service that you're working on, or who knows what. You can also download an 8 version, a Java 8 version with Graal in it from the Oracle Technology Network. So Oracle Labs provides a binary for that, if that's your only way out. And with that, please try it. Thank you very much. And yeah, the hands already go up, so yes. All right, first row. Why did the early talk by Christian, where I think you AOT compiled Scala C, I think that was it, right? Yeah. Why did they get a 30% improvement, but we only get 10? The answer is Scala C stinks, right? It's shitty code. We have, now I've been told this many times, I have no idea about Scala, but I know that Scala C is a slow compiler. And so if you can, well, yeah. So if you can improve that, one big issue with Scala C as far as I know, and Java C has the same problem, is the JVM startup is not very fast, right? So if you can improve JVM startup, you can improve a lot on that front. But this is like a running, this is a running service that runs for hours and hours and days. So you can't really compare a source code compiler to something like a service. You know what I'm saying? Does that make any sense? It doesn't look like you're happy with the answer, but well, then I changed my answer to.
It probably is more.
No, but I mean, like everything, there's an answer for you, and the answer is it depends. Yeah. It's like it depends on the code. It really does. I have to repeat the question. So where does Graal stand right now with vector instruction support compared to C2? So there are two ways or two usages for vector instructions in C2. One is in intrinsics, like handwritten stuff. That you can just, maybe you already have that, like the contribution I showed you was basically SIMD instructions porting over. That's the handwritten part. Then maybe you were talking about loop auto-vectorization. That's what you were talking about, yes. There is no, as of today, as far as I know, there's no loop auto-vectorization in the open source version of Graal. There is one in the closed version, but I think I remember an email not too long ago that they're actually open sourcing that part now. So the question is, if I tried the same inlining parameter tweaking with C2.
Yeah, with max inline level.
Sure. No, I did not. It potentially will help, yes. The reason why I didn't do it is because I want to get rid of it. Right? Sure. So the question is how stable Graal is regarding de-optimizations and latencies and things like this. Yeah. Okay, so if you talk about de-optimization, like what I think you're talking about, like de-optimizing from compiled code into interpreting, is that what you're saying? Yeah. I mean, that's very difficult to answer. The answer I can give you is we are not seeing this. So for you, if you really have that issue and you think you're constantly de-optimizing and recompiling, you would have to look at the compilation output and see where this is coming from. But we don't have that, no. It's very stable. I told you, I mean, this, we're running thousands of instances of these services. We deploy them multiple times a week. So they start up a lot of compilations going on. I can tell you there's a ton of de-optimizations happening all the time. But it stabilizes itself. Like it gets to its peak performance and it stays there. So it's not any different than C2. Not for us, no. Does it help with I/O operations as well? Is that your question? I mean, we do a lot of I/O as well, but it can't really help with I/O. right? Because I/O calls out into the kernel and then you wait for it. There's nothing the JVM compiler can do about it. But it's like the logic that runs on top of it. It's like all your business logic that Graal can optimize that, but not I/O, no. He wants to know again what versions of OpenJDK have Graal in it. There's on Linux x64, 9 has that.
Not 8.
Not 8.
Okay.
8 you can get from the Oracle Technology Network. If you type in Google OTN Graal, the first hit is the one you want. You can download an 8 version from there. JDK 10 has Graal in it, and for all the
JDK 10 or OpenJDK?
it's well, in 11 it's the same thing. In 10 it's almost the same thing, right? So it's OpenJDK. In OpenJDK 10 you have Graal, yes,
Okay.
for all the platforms, so Windows, Mac, and Linux. Well, really good results. Yeah, I mean, the reason why I'm not talking about enterprise Graal is it's a philosophical one, maybe, but okay, why not? It's like the last talk for a while for me. Maybe the last one forever. No, I can say that. So we were experimenting. Like I did the same thing as here with the tweet service in the experimental setup. I tested open source Graal and enterprise Graal. And with open source, it was like 10, 11%, right? And then we got like 13 out of it when I tweaked it a little bit. And with enterprise Graal, it was 20. But it costs money. That's the philosophical part, by the way. So the question is, if I think that the source code will change so that it will run better on Graal than it does now on C2. It might. Well, so when I say that source code has been optimized for C2, it almost exclusively has to do with how big methods are. Because inlining is the mother of all optimizations, right? And inlining can give you a lot of improvement or can destroy everything. And so people, when they did benchmarking, they might have reduced method sizes so that they got inlined with things like this. And Graal's inlining just works differently. So it might change on that front. I don't think there are any code patterns that work better on C2 or Graal. Yeah, maybe because the loop vectorization or whatever works a little differently, but I don't think so. I think it has more to do with how big methods are and how the factor, how you factor your code basically. But that was always a pain point with C2, just the way the inlining is implemented in C2. It's very stupid. And Graal's inlining policy is much, much smarter. So the need for doing this should be less. I hope that's the outcome. We have one, because you mentioned code patterns, and maybe I should mention it here. We have one guy on our team, Flavio. He's a Scala guy, right? He knows Scala code. He's not really a JVM guy, but he knows all the Scala stuff. And so he's looking at Scala patterns right now that can be optimized by Graal better. Because that's important for us, right? The typical whatever Scala patterns you use every day. Maybe we can do something in Graal to optimize these better. So we were looking at this. I hope it helps. We'll see. So the question is, if we're running all of our services on Graal or just a subset, the answer today is only a subset. The first, almost 2 years, I would say, that when I joined Twitter, especially in the first year, and you can imagine, I come to Twitter and then I say, hey, and I go to a service owner, right? And say, hey, there's this experimental JIT compiler that no one's using in production. Would you like to try it? What do you think his answer was? So everything I did at Twitter in my first year was not software engineering, it was social engineering. I was hand-holding a lot of people's hands. I say, it will be fine, it will be fine. So it was hard for me, when I got the first big services, then it was easier because I could say, hey, look, this big service runs fine, maybe you want to try it as well. So right now it's maybe 20, 25 services that run on Graal out of hundreds. But after, as I said, this is the last talk for a while, the next step for us will be to switch all of them. So we've implemented some logic internally where we can flip the switch and then all of our services are running on Graal. That should happen in the next couple months. And I hope I get a cut of the money savings. More questions? Last chance? Or you can ask me outside if you want. Thank you very much.